Hi everyone, again welcome to the Linux programming and scripting class. We will be talking about Perl in today's lecture. Um, let's look at what we covered in the last lecture, um, and then we can start from there. So let's quickly go through that. So in the last lecture we had a lot of things that we covered. A lot of the things were new to most of you. One thing we went into like more details about the pattern matching. I mean this is one of the key things that you want to understand in Perl. Then we also took we took a look into the Perl debugger, the various debugging commands that we went through. And I think like I mean that's another thing, like I mean once you run into trouble with any Perl programs, you can invoke the Perl debugger and then use the Perl debugger to actually debug your program. That will be like very useful. And then we also looked at the functions, some of the functions in more in-depth manner. One was grep. The grep is a function that is used to grep particular word from given array of words or given dictionary. And actually like I mean grep is used widely to compare two arrays and get the difference of the array, or also compare two arrays and give unique items or the inverse of the differences, essentially meaning or the commonality between the two arrays. That's one thing, and then also like the difference of the array as output, and then these things can be used by simply the function. We looked at it basically how we can combine the hash table concept or hash array concept, and then use grep to actually grep from that the indices essentially. So that's one thing, and then the sort, actually here we also went into more details. Here actually like I mean in the last class we introduced a new operator called the steamboat operator, essentially like this operator is used as a moniker to do the sorting. The regular sort is an alpha sort essentially, so there's a lot of issues basically. So when you have to have a numeric sort, and also like I mean how do you do the um, numeric sort and ascending order and descending order, how do we do all those things we can achieve using the steamboat operator. One thing to note here is in Perl the sort function is by using a quicksort algorithm. So essentially as you know, the quicksort algorithm basically like just starts with any one variable, any one element in the array, and then it tries to sort the elements that are greater than that element after that element, and then the elements that are less than that element before that element, and then once it basically like once it anchors that particular element, then it passes these two lists, and then again it continues the same way recursively it goes through. So typically we see that it has a complexity of n log n. I think like I mean you'll probably like get into all these details once as a real computer science. At least to know here you want to make sure that this complexity is in this log n area. N log n is kind of, it is very good considering the sort. If it is n squared, that means that you are actually like going through the object in 2 times basically. So I think like I mean this is a much controlled behavior. So that's what we are using the sort. So sort is fairly efficient. So that's what I want to say about that. Then we also looked at the file open, file close, testing the files with various switches, whether we can read a file, write a file, things like that. And then also like in the same case for the directories too, basically these tests can be done for the directories. And then how do we open the file and various file handles, things like that. We talked about that. And then we also talked about the strict keyword, essentially. So this is to make sure that Perl does not um, omit any kind of warnings or any um, other errors that it encounters, because Perl itself is a tolerant program. So even if you made a mistake, but if it is syntactically and semantically correct, it just lets those things go through. So I think strict is one keyword that we will be using. Basically, it's the use strict. We will see like more and more programs actually using this. So initially, like I mean, if you're doing like simple programs, you may not want to do this, but once if you're doing any Perl programming development, I'll strongly urge to use strict in your programs. So I think this is pretty much like what we saw in the last lecture. I think like I mean we went into like a lot more details in a lot of these areas. But today I want to actually introduce two topics today. One is there are some leftover items that I want to talk about. One of them is essentially like how do you run a program within a Perl code. So there are some neat techniques for that, and I will explain that. And then the big topic for today is some of the object-oriented features of Perl, which is actually prominent in the Perl 5, which is the 5th generation Perl. And this is essentially what is called the packages. Essentially, today we will talk about how do we use packages. Basically, like I mean, one thing that made Perl a versatile language that exists today is the ability to actually export and import modules from different sources. So we will see like I mean motivation behind that, and then also like I mean, how do we really do it in when we talk about the packages. So let me talk about the first ones. Essentially, as I mentioned, how do we run programs inside Perl? So say like I mean you want to do externally like I mean a CD into a directory or something like that inside of Perl. How do you do that? So we'll see. There are actually three ways of executing commands within Perl. The first one is what we call as exec or exec. The exec commands essentially it executes the command that you provide, but it never returns. So this is the keyword, the never returns. It's like a written statement in a function. If the command is not found, the exec returns a false. It never returns true because if the command is found, it never returns at all. There is also no point in returning standard out, standard error, or exit status of this command. So some examples essentially like here exec foo or print standard error couldn't execute foo with dollar bang. I think like I mean this one you already know about this. Basically this is to print the error message number. So it gives the constant error message number for this particular error. The other way to run exec is just enclose the whole statement within the curly braces, and then essentially you can also if this returns 0, then it goes into the next statement, which is it will say that it's not able to execute. So exec pretty much like finishes a program. So basically like I mean once you run the exec, it basically it just comes out from that program. So this is one method. There are places where this gets used. So we'll talk about it. Talk about some of the things, but it's one of the useful commands. The second one is called system. In system, essentially, like once you specify the command, it executes the command, and then once the command finishes, basically the Perl script is continued, and then it goes through. And the return value for system command is the exit status of the command itself. So if you are doing a CD and the CD becomes successful and if it returns 1, the return value from system is also 1. But if that CD was not possible and it returns a 0, then the system command also returns a 0. Again, it's mildly useful, but it is not really useful because, as you know, when we try to execute commands, yeah, we can execute command like CD, for example, is to go take the program pointer to a different directory. But if something like if you are using an external sort or a find algorithm to find certain things, how do you actually get those values and then process them further? That's simply not possible with the system command. So here the example for using the system command is command with arguments, and they are within the double quotes inside the parentheses. And then a better way is essentially like enclosing command arg1, arg2, arg3, everything as its own strings, so that it's actually better for the system to see it and then run the system command. Now the third option that you have is what is called a backtick, and this is, I think, like this is very prevalent one, and then a lot of people use this, and essentially this is something that that's you will be using in your programs as well. The difference between the backtick and the system is it is like system where it executes a command, and the Perl script is continued after the command is finished, just like the system command. But where the difference comes in is essentially the next line here, where contrary to the system, the return value is standard out of the command. So if you do the backtick, it's not the status, but whatever goes into the standard out becomes the return value. So here we can say, like in a scalar context, dollar result is command followed by arg1, arg2, and then you notice the backtick here, so this command gets executed, and essentially, like whatever the command's return value is stored in as a scalar into the dollar result. And then if the command actually returns a list, then all you got to do is basically, like you can store it as an array with result as the name, and then execute the command in the backtick mode, and then whatever comes up is stored as an array, basically whatever the result of that command. So this is very useful when you are doing a sort, external sort for some reason, and then actually using it and storing it into the result. So again, to recap on this one, exec essentially, like it basically it executes the command, but it never returns. So it's useful, but it is not that useful. The system essentially, like this is the next best thing, where system actually returns the exit status of the program of the command, rather than actually any other thing, basically whether it's an output of the command or anything. It doesn't produce that. It only produces the exit status. So here, if you want to use this, you may have to store the values into a temporary file, and then basically, like again, read it back into Perl, and then you can use it. So like system command is typically used to generate like large amount of data, which will be used at some point of time later in the program. So that's the system, and then finally the backtick commands. The backtick commands essentially it's just like the system where it executes the command, and the Perl script continues after the execution is finished. But the difference is that actually now you can pass on whatever the output of the particular command back to the program that initiates this call. So it can be passed to those things, and then you can do further processing with that. So the backtick is like a very useful. I'll say like I mean more often than not you'll see the backtick commands than um, the system commands. So now that we covered this, let's see the next one basically, which is how to write and use Perl modules. Again, remember that this is basically it is Perl 5, which is some people call as object-oriented Perl. But I think like I mean the key thing here is essentially if you are developing programs, how do we um, get it into another Perl program, and how we can foster like a collaborative development of various Perl systems. In fact, today a lot of companies, whether it's hardware or software, are using um, Perl as a vehicle. I mean, use are doing Perl programming, and the way that they do it is collectively they are doing it, and then in order to make the system work, we need these modules, the concept of modules, and how do we actually write and use them. So just before that, I wanted to introduce you one small function which is called the QW function. It's called quote word. It is used to generate list of words. The QW actually extract words out of the string using embedded white space as the delimiter. So this is important. You can actually like change this delimiter to any other delimiters that you can read up on that for this command, particular command. And then it returns words as a list essentially. So and then it also one thing that one thing to note is that it happens at compile time. So which means that the call to the WQ is replaced with the list itself before the code starts executing. So here one simple example is quote word temp file tempdir. It returns temp file and tempdir as two different values. So now, so this is important in the next section when we talk about the modules, because like I mean most of the modules we write it as um, functions and basically use quote word function a lot. So let's look at first of all what is a module. So the module is essentially a separate namespace in a separate file with related functions and variables. So there are three things here. One is a separate namespace, another one is separate file, and then there are related functions and variables. So how do we do that? We will see basically. So what is a namespace? The namespace provides a certain context to the function and variable. So essentially you can think of namespace as any kind of names itself. So my hammer, Mary's lamb, Gulliver's travels, Dutch cheese, French bread, your car. So you can think of this as like this. These pronouns here basically are various possessives here basically. These are all the namespace that that's basically like I mean that provides that context to these functions. So if so in short, essentially, like I mean, you can say like two people writing sort function. You can say like A is sort or B is sort. So we will see more about that context essentially. So here one example. I have like two engineers, Jack and Harm. They both wrote a function to shuffle a sequence, and you want to compare the two functions. They both call this function as shuffle. Now, how do you distinguish between them? So the way to distinguish between them is to put the function in its own namespace. So now we call the first one as Jack's or Harm's. So there's a sub shuffle, and this is Harm's implementation, and then there's also a sub shuffle, which is Jack's implementation. So if you put basically say like I mean this is the sequence that we need to do, and then if you say like I mean shuffle seq, this will not work because it doesn't know like I mean okay which function to use. Again same thing, it does not work. So we need to distinguish between this and this. So how do we do that? So again it's all the same basically like I mean the top one, and then what the sequence that we want to shuffle is also the same. Only thing is like now we name the functions as shuffle Harm and shuffle Jack. So you notice here that actually like now these names are different. We add this additional element to it. Yeah, this is well and good, but what happens basically when we we have to somebody has to tell the others essentially like I mean like if say like Jack is the one that is that developed the shuffle second time. Now Jack needs to, at least Harm needs to tell Jack that hey Jack, I'm using the name shuffle Harm, so you should use shuffle Jack, or everyone should have these kind of names arbitrary. This is kind of arbitrary, you can see basically. So to avoid this essentially we use the package essentially. So what we say is basically like we will have the package as Harm, and then inside that we will still use the same name which is shuffle, and then that is followed by the Harm's implementation, and then we will have Jack's block with a package called Jack, and then it also has the same thing as a function which is shuffle, and then this is Jack's implementation. So now we define these two things, but how do we use them basically? So the way to use it is like again like I mean, the sequence is the same. Here we use Harm as the package followed by this colon and then the function name. Here again the same thing for the Jack, it's basically Jack colon and then the function name. These two will work basically, and then you will get like two different answers based on how each one implemented these two functions. So so this is the package that we can see basically like I mean so the package is essentially like I mean something that is used inside the same program. So essentially like I mean so now if you want to compare these two packages, basically like you need to put these two packages, copy from Harm's area and put it into your program, copy from Jack's area and the shuffle and then put it in the program, and then we need to write the basically like then we can write the whole program to work with that. Again it's kind of cumbersome basically like I mean so one thing that we want to do is we don't want to even depend on Harm or Jack in order to develop our program. So for that we need to turn these packages into modules. So to turn this into modules, we save Harm's package as harm.pm and Jack's package as jack.pm. But one small change that we make, we put this one semicolon as the last line of each of the form. So then they are packages. So then Harm can check in his module. I mean these packages are converted into modules now. The Harm can check in his module, and then Jack can separately check in his module, and then they are somewhere basically. So in order to use these modules in our script, basically what we need to do is we need to use the keyword use followed by the package name. I think like even you already saw the use of the keyword use, essentially like use warnings, use strict. These are all the various ways that we were using this. And then the name of the module file usually is the name of the package, basically with the extension PM. So essentially like so we just say basically like use and then use Jack in this case. So here let's see like how we do it basically. So the harm.pm itself, the way that we'll write is we use the same use strict and use warning. We call it as a package HARM, and then we write the shuffle. And then you can see that the one semicolon is there. Now in the Perl script, the way that we can do it is basically use harm and use Jack. These are all the package names essentially like because the file itself is stored with harm.pm. So this is the packages. So we kind of imported these packages from these locations. Now we give the same thing, and then this is the same exact command that we saw, and then this should produce the right expected results. So we can also export functions by the modules into the main namespace. So here we basically like we use what is called an exporter, and then essentially like we specify using the code word the exporter into this array, and then export is nothing, and basically like this is another variable. These are the two preset variables that we will see what they represent in the next sections. So the export OK functions have to be explicitly imported basically. So essentially like what this means is like once we add this in front of our programs, essentially that becomes the modules or the functions that can be exported. So actually there is a E missing here, you can say basically. So we say basically like for the shuffle function, the export is okay for that particular function, and then that's how. So that's what we mean here basically like functions have to be explicitly imported. So here essentially like again we use the same thing basically, and then we say like shuffle sequence, and then we will say like Jack shuffle sequence. So see here that actually like we don't need to specify harm anymore here. That the reason is basically like we cannot we don't need to put the harm because this is something that is what is being exported from this function. So for the harm actually like we are using this, so basically like it is directly exported into this main namespace, so you don't have to specifically assign a Jack namespace for that particular shuffle. So wherever you call shuffle, it's assumed that it's basically coming from harm. Okay. So the location of the Perl module is the other thing basically that we want to talk about. Essentially, it's essentially like it's specified in this at inc array. So once you have the Perl minus v, which is the verbose option, then you can actually like print this at inc to see where Perl looks for modules um, um, in your path. So and then you can also add this path with the Perl 5 lib environment variable, which is use lib and then path to the libraries. So now the question is like why we use modules. So as I mentioned, basically like there's one reason, which is the sharing and code development of various programs. But let's look at this essentially. So the number one reason is essentially to organize the components of the program. So what we can do is when we have like large programs, we can develop some of the components as a bottoms up approach, where we write the essential functions, and then those functions can be stored in various files, and essentially like we can use an export mechanism or modules to export that into the main program. So this is one reason. The second reason is the code reuse, where we can use the same once we write a particular sort function, and if we know that that is the most efficient way of doing things, we can use that over and over again in other scripts, and we don't have to develop this at all. We can reuse the code from one to the other. And then the third main motivation for using the modules is it's a convenient way to publish or share the code with others. So there are a lot of modules and a wide range of functions are available for Perl. So this is one website that I want you to go and check for the various modules in Perl. So some more details on the modules. Modules are an important and powerful part of Perl programming language. The module is a named container for a group of variables and subroutines which can be loaded into your program. By naming this collection of behaviors and storing it outside the main program, you are able to refer back to them for from multiple programs and solve problems in manageable chunks. As I said, this is essentially like promoting the reuse mechanism. The modular programs are easily tested and maintained because you can actually test just the modules and maintain them, and you can avoid repeating the code. And then the main reason why we can avoid repeating the code is also because we need to change any kind of bugs in only one place, and then all the others automatically gets changed. And then Perl modules may also contain documentation. They can be used by multiple programmers without each programmer needing to read all the code. So essentially it promotes multi-user and multiple people to work on programs simultaneously, and it also promotes developing a big environment which does several things, collection of tools and techniques basically for solving a given problem, and it can be generated by that. And then the modules are foundation of the CPAN, which contains thousands of ready to use modules, many of which you will likely use on a regular basis. So with Perl installation, the CPAN modules also comes, and then you can use them for your programming purposes. So I want you to take a look at the CPAN. The website is given in the previous one. So now let's look at what is CPAN. So before that, like as I mentioned, the Perl modules, they are set of related functions and in a library file. They are specifically designed to be reusable by other modules and programs. Currently, there are about 108,000 modules that are readily available for your use. So what is CPAN? CPAN is this particular thing. Basically, it's a comprehensive Perl archive network. I want you to go and like look for it because the CPAN function CPAN modules are widely used, and pretty much it comes with every Perl installation. And in your installation, it will have this thing. And one thing to also note is most Perl modules are written in Perl, but some use XS, and they require C compiler. Modules may also have dependencies on other modules, almost always on CPAN, and cannot be installed without them. So, or we need to also without a specific version we cannot install. So, and then the CPAN itself, in the modules in CPAN, they require a recent version of the Perl, which is Perl 5.8 or above. So this is another location, essentially like metacpan.org, where you can search the 108,000 modules I mentioned on CPAN. So think of these modules as now your apps. Only thing is like these apps are actually connected to each other, so that I mean then you can write a super app by just meshing these apps into that super app. So essentially, like I mean, and then so this and CPAN you can think of it as the iTunes for Perl, and that has about 108 modules ready, 108,000 modules ready for you to develop the new apps. So I think like I mean this gives you like a good overview. Essentially, now we will look at the one code segment. Basically, like I have one today. Here, essentially, like we are trying to list the contents of a directory. So the first statement, basically like use in Perl, use strict, use warnings. So here we are actually now exporting a module essentially called path, and then basically like which contains the package class. So here essentially like I mean again we are defining the directory basically. So it's foo bar, essentially that goes by foo/bar. You can have like many more, and then they're all like we are opening it as a directory, we're calling it as a directory. And now we want to iterate over the contents of the foo/bar. Basically we are saying here this particular scalar variable is $dir next, essentially the next file. First we see basically like if it is a directory, then we'll skip basically. So we do a isdir test essentially on this particular file, and essentially we just break the loop and then go to the next one if it is if the test becomes true. If the test is not true, then what we do is we basically we print that particular line into the as a string and with the new line character. So the stringify is another function that is specified in this one basically, which essentially like takes this contents of the file, which is the foo/bars first one, and then it creates a string out of the whole characters, and then it prints out that particular string. So I think like I mean this is a very simple program, as you can see like I mean so this is, you can think of this as the ls command essentially. So ls and directory name you get, or ls foo, you get this particular Perl command. You can see that 1 2 3 4 5 6, 7, 8, 9. About within less than 10 lines, you can actually make this command work. So this is how powerful you can see the programs, and then how powerful it can get. Um, so I think let me just recap this whole session basically for you. So we started by talking about how to execute commands inside of Perl using the three main methods. One is the exec, which is not very useful because it executes a command and then it comes off. So you can put it as a like last command basically. If you want to send an email or something, you can execute the email command and then just come out or something like that. Then we also looked at system. The system specification is essentially it executes the command, but it continues from where it is where it left off, and until the Perl script itself is finished. But the return code is actually the exit status of the command. It's nothing. It's not the output of the command, but just the exit status of the command. It's true or false. So you have to use it with a pinch of salt here. Basically, if you don't want any output coming from the particular command to be further processed, then you can use a system call. Okay. And then finally, the backtick essentially is essentially like a backtick is the way that we can actually capture the results or capture the output of a particular command into various variables, and this can be used within the Perl script itself. So there are a couple of examples that we quoted here. You can think of this basically like you can have it in a scalar context or an list or an array context. So these things you can do. Then the next one that we talked about was how to write and use the Perl modules. This is one of the advanced topics essentially, like I mean this is also known as the object oriented Perl or Perl 5. One of the function that we talked about, which is key to all these things, is the QW or the quote word, and this is used to extract words out of the string and using the embedded white space as the delimiter, and it returns the words as lists. So a simple command is shown here essentially. And so then we went into the packages and the modules essentially. The modules essentially is the separate namespace in a separate file with related functions and variables. So we wanted to understand what the namespace is, and the namespace is something that provides a context to the functions and variables. So if you can distinguish between A's sort function and B's sort function. And then we explained the namespace with an example, essentially like where we have two individuals, Jack and Ham, who are trying to develop the same program called Shuffle, and how do we distinguish between them. So if you just put the function name with those two implementation as functions, that does not work. So one way to come up with a solution is basically embed their names into the function. So it is Shuffle Ham and Shuffle Jack. Yeah, we can do this, but this is again cumbersome, and basically it will be all it's a very subjective, so we cannot really implement this. So in order to find a happy medium, what we said was basically we introduced the concept of a package where we start the Ham block with what is called a package specification or package keyword, and then Ham, and then we write a shuffle. And then for the jacks, basically Jack also starts the same way, package Jack, and then the his shuffle. And then once we use it, basically we just say Ham colon and Jack colon. So this is the way how we can um, import those packages into our program and then use them. But the package can be turned into modules by just using the one followed by a semicolon at the end of the program, or the last line of the program should have this. And then if you want to use the package in the script, we use the keyword use followed by the package name, and then we don't have to specify the extension PM here. So here basically how we use it, we do the define the harm.pm with one semicolon, and then we use it inside the thing, basically just harm. We give like this keyword use harm to make sure that this package is exported. So another way to do it is essentially like, I mean, you can actually export it into. So this is a simple export essentially, like, I mean, use harm and jack, but you can also give it a main context essentially, or you can export into the main works namespace, so that we can avoid every time typing these some name followed by colon. It will have a name in the main in the mains context. To do that, we use an exporter. So we specify use exporter, and then we basically like specify these commands, and essentially we say that export OK is shuffle, and this actually gives um, um, the the command actually, like, I mean, how to do it. So the we say basically use harm, and then again the shuffles as the subroutine essentially. Like, so once we say that this is the subroutine and with this package, that one we don't have to specify the harm anymore, basically, because it's also matches the export OK, and then we continue with that uh, process. Then we talked about the locations essentially, like, I mean, and how to look at the libraries, and then we talked about the why we use modules. Again, the three reasons that we outline are: one is to organize the components of your own module, your own programs; then to promote the code reuse, where you develop once and share it and then use it many times; and then sharing the code with others. Essentially, this is the key thing why how the collaborative design environment can be developed. And these are all like the functions are all available in cpan.org, which is an archive essentially. The cpan itself stands for the Comprehensive Perl Archive Network, and currently it has about 108,000 modules. And one thing to note is, like, not all the modules are written in Perl. Some of them are written in the XS, and they also require a compiler. And then we also want to note that the modules themselves basically call other modules, and so essentially, like, we need to install the whole thing to get all the modules. And then the recent version of Perl is that's another thing that we need for accessing cpan modules. So the Perl version has to be 5.8 or above. Okay, so I think and then we went into this one example where we just wanted to list the contents of a directory. This doesn't check other things or does not have any other things. Basically, this is kind of like it's an ls minus l, so it does not check whether there are any like dot files, things like that, or any other further checks on that. Only like directories it avoids, and it only prints the um, all the regular files. So even ls minus l actually prints all the directories and everything. This only prints all just the files. So I think this is pretty much it for Perl. From the next class onwards, we will start the Tickle programming language. I hope this was enjoyable. We will have some quizzes coming up. I think your TAs will organize some of the quizzes and tests for Perl. So thank you very much. Okay, bye bye.